of designers around.
Main, kita dah. Alah, malah.
Am I audible?
Yes, madam. You are audible. Good morning. Vijay Padma, madam. Good morning. You are audible.
Hello, Vasant. Am I audible? Vasant.
Arun.
Sir.
Audible, yeah. You.
Okay, sir. Thank you, sir.
Audible. And madam voice also audible. She is not responding.
Am I audible now?
Yeah, madam.
$10.29. 10:30. Oh. On the screen or not?
என்ன சொல்லுங்க?
Yes, sir. Yes, sir.
Morning all. I request all the participants to wait for the VC to arrive. Thank you.
இப்போ நான் எப்படி இப்போ நான் இதில் தான் இருக்கிறேன்.
இப்போ நீங்க உள்ள வரீங்க வீடியோ மட்டும் ஆன் பண்ணி சார் சாரோட வீடியோ ஆன் பண்ணி
ஓகே
குருசாரன் வந்தா கோர்ஸ் போட்டு
அதாவது அந்த இது நம்ம அந்த பேச வேண்டியது அந்த ஃபைல் அந்த ஷீட் இருக்காங்க. விஜயா மேடம் ஆடிபிளா இருக்கேன். சார் ஐ எம் ஆடிபிள் சார். பரிமளன் சார்.
Yes, sir. Yes, sir.
Okay.
Audible.
Okay, okay, sir. Okay, thank you. Vijay Padma madam, good morning madam. மேடம் இருக்காங்களா? இது எப்படி பண்றது? பார்க்கறது
மட்டும் கிளிக் பண்ணுங்க.
மேடம் இருக்காங்களே?
கனெக்டிவிட்டி ஆடியோ உங்களுக்கு வருது.
இப்போ வருதா? மேடம் குட் மார்னிங் மேடம். மேடம் குட் மார்னிங் மேடம். குட் மார்னிங் மேடம். நாட் ஆடிபிள் மேடம். வாய்ஸ் மேடம் வாய்ஸ் வரலையே. இல்ல மேடம் வாய்ஸ் வரலங்க. மியூட்ல இருக்கா? அன்மியூட் பண்ணணுமா? அன்மியூட் கொடுங்க. அன்மியூட் கொடுங்க. இல்லையா அவங்க தான் அன்மியூட்
நான் ஃபோன் பண்ணியே சொல்லுங்க.
audible madam, audible. Yeah, thank you. அவங்கள சொல்லிருங்க பிசி.
Hello, ma'am. Ma'am, we can wait for the VC's arrival, ma'am. Just 5 minutes, ma'am.
Yeah.
Thank you, ma'am. நீங்க வந்து பேசி
Am I audible, sir?
Yes, madam, you are audible.
ஹலோ சார், ஆடிபிளா இருக்காங்க சார்? ஹலோ,
Good morning, all.
audible sir?
ஓகே சார். எங்க லைன் கிளியரா இருக்குல்ல?
Okay, thank you. Your internet connection is unstable.
Good morning, all. On behalf of the Department of Botany and Department of Biotechnology, Bharatiyar University, I cordially welcome everyone for the 3-day international seminar on advances in biological sciences. Now, I request Dr. B. Vijaya Padma, Professor and Head, Department of Biotechnology, Bharatiyar University, to deliver the welcome address. Please, ma'am.
மேம்,
Yeah.
ஆஃபீஸ்ல இருந்து பிரசாந்த் பேசுறேன் மேம். மேம் கேக்குதுங்களா மேம்?
Yeah. Can I start now?
மேம் இல்லங்க மேம், 5 to 10 minutes மேம். இப்போ சார் இன்னொரு ப்ரோகிராம்க்கு இனாகுரல் பண்ணிட்டு இருக்காரு மேம்.
Okay.
ஒரு
Sure.
5 மினிட்ஸ் மேம். அப்புறம் சார் பேஸ் தெரிஞ்சோட நீங்க வெல்கம் அட்ரஸ் கொடுக்க ஆரம்பிச்சிருங்க.
Sure, sure.
தேங்க் யூ.
அருண் சார், அருண் சார், ப்ளீஸ். ஓகே, audible. நல்ல கிளியர்.
Guru? Guru? Dr. Guru?
Perfecter.
Dr. Guru?
Very sir.
Dr. Guru,
Very sir.
your face is not visible here. I think there is no light.
Oh, my face, sir.
Please check. Yeah, now it is okay.
Very sir, now okay.
Yeah, it's good.
Sir, am I audible?
Yes, madam.
Sir, am I audible?
Ma'am, is this my ma'am?
Yes, yes.
Can you hear my?
Yeah.
Okay, madam. Okay.
நான் லேப்டாப்லயும் மொபைல்ல கனெக்ட் பண்ண எதுல கனெக்ட் ஆயிடுச்சுன்னு கன்ஃபியூஸ்ட். I don't know. I got connected with both the devices. Which where I'm audible, புரியல. That's what I was confused. ஹலோ அருண். ஆமா ஆமா எனக்கு எதுல கரெக்டா இருக்குன்னு எனக்கு தெரியல. ஓகே 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 அப்ப இது க்ளோஸ் பண்ணிடு.
Yes, sir.
Dear participants, do you hear me? Am I audible? Dr. Gurusaravanan, admin.
Yeah, audible, Guru.
Audible.
Arun, audible.
Hello.
Prasan?
ஆனா 2 minutes சார் வந்துருவாங்க, ரெடி ஆயிக்கீங்க. எக்கோ சவுண்ட் கேக்குது, மத்த எல்லாத்தையும் மியூட் பண்ணிருங்க. சார்தும் மேடம்து மட்டும் அன்மியூட் பண்ணிட்டு மீதி எல்லாத்தையும் மியூட் பண்ணிருங்க.
Okay, sir. Okay, sir.
2 minutes சார் வந்துருவாங்க. Thank you.
Okay, sir. Sure, sir.
Prasan?
Sir.
சார், குட் மார்னிங் சார்.
Yeah, good morning, Prasan. கேக்குதுங்களா?
கேக்குதுங்க சார்.
Right, Prasan.
Thank you, sir.
Good morning, sir.
Dear participants, please wait. We are waiting for our VC to come.
I think he has come. He has already joined, I think. Just check.
மேடம் என்ன சொல்றாங்க?
Am I audible?
Yes, madam. You are audible, madam.
Because
Clear,
I saw Vice Chancellor's this thing icon. He has not come yet.
Actually, he came, madam. Waiting for 2 minutes, madam.
Okay.
Already, he came. He entered.
Yeah.
நீங்க இது பண்ணிட்டீங்களா? Yeah, madam.
Yes, sir.
Yeah, madam.
Yes, sir.
Sir will come now. Just 2 minutes. Vidya madam, just introduce madam, Vijay Padma madam. We just
Sure,
call.
sir.
Okay, then only we'll
Oh.
start.
Okay, sir. Good morning once again. Now I request.
Wait.
Sir.
Sir is not coming.
Okay. Sir.
Vidya madam unmute பண்ணுங்க. Vidya madam unmute பண்ணுங்க. Okay.
Okay, sir.
Okay, fine. Vidya madam. Sir,
Good morning.
Start the sir.
Morning. Good morning,
Yes, sir.
sir.
Good morning, sir. Good morning.
To all.
Good morning, sir.
Good morning, all. On behalf of the Department of Botany and the Department of Biotechnology, I cordially welcome everyone for the 3-day international seminar on advances in biological sciences. Now I request Dr. V. Vijaya Padma, Professor and Head Department of Biotechnology, Bharatiya University, to deliver the welcome address. Please, ma'am.
A very warm good morning to all the dignitaries and participants of the 3-day international webinar entitled The Advances in Biological Sciences, jointly being organized by the Departments of Botany and Biotechnology. First and foremost, I would like to introduce our Chief Patron, Honorable Vice Chancellor of our university, Professor Dr. P. Kaliraj. He is an eminent scientist and great academician. Before coming here as our university Vice Chancellor, he served at various senior positions at Anna University, such as Director and HOD, Center for Biotechnology, Dean, and also as Interim Vice Chancellor of Anna University. He is basically a biotechnologist and entrepreneur himself. He has patents and commercialized products to his credit. He's an inspiration behind us and instrumental in bringing DBT-sponsored medical biotechnology course to our department. He also introduced several changes in the curriculum, such as bringing in outcome-based education, which is UGC mandatory for UGC institutions. However, he also introduced revolutionary changes, such as introducing introduction of courses such as Industry 4.0 and 5.0 based courses, and also job-oriented and value-added courses to our in the curriculum to increase the employability of the students. We are very happy and honored to have you here, sir, for this webinar series to deliver the inaugural address. Here, we are blessed to have you here, not only for your biotechnology background, but also for your entrepreneurship skills. We strongly believe that you are an inspiration for us and as well as for our student fraternity. I hope you will also inspire our audience with your fascinating and infectious speech during the inaugural address. Now I welcome Dr. K. Murugan, Registrar in Charge, Professor and Head Department of Zoology, Bharatiya University, and Dr. Ramesh, Dean, Research, Faculty of Science and Professor of Zoology. And also I would like to welcome Dr. A. Rajendran, convener for this webinar and Professor and Head of Department of Botany. We also welcome Dr. T. Parimelagan, who is also a co-convener for this webinar series, Professor in Botany, Bharatiya University. And also I would like to welcome all the faculty members of Department of Botany and Biotechnology, who are also instrumental in helping in some way or the other for this webinar series. And now I would like to introduce all the delegates, the people who are going to deliver lectures or invited speakers. First, I would like to start with Dr. Kevin Eboy-Bodin. He is an adjunct professor and vice president, R&D and quality quality and regulatory measures at lab systems in molecular biology at University of Helsinki, Finland. and Dr. R. Rajesh Kumar. He is a research scientist at the Institute of Nuclear and Agricultural Sciences, College of Agriculture and Biotechnology, Zhejiang University, China. And then I would like to call up, invite Dr. G. Ashok, Associate Professor, Department of Microbiology, Faculty of Medicine, Director, Center for Infectious Diseases and Phytomedical Studies at Quest International University, Perak, Ipoh, Perak, Malaysia. Dr. S. Karthikeyan, Medical Faculty, Martin Luther University, Halle Wittenberg Institute for Medical Immunology, Magdeburgers, Germany, and Dr. T. Muttamil Selvan, Postdoctoral Research Fellow, Department of Integrative Bioscience and Biotechnology, Institute of Life Science, Pohang University of Science and Technology, Pohang, South Korea, and Dr. K. Chandrasekhar. He is also a postdoctoral researcher, School of Civil and Environmental Engineering, Yonsei University, Republic of Korea, and Dr. S. Vinod, PDF, National Naval Orange Engineering Research Center, Gannon Normal University, China. He is also an assistant professor in biotechnology at Sona College of Arts and Science, Salem. Finally, I would like to welcome all the participants of this international webinar series, which include faculty and students from our university and from other institutes across the globe. Thank you, one and all.
Thank you, ma'am. Now I kindly request our Honorable Vice Chancellor, Professor Dr. Kaliraj, to deliver the inaugural address. Please, sir.
Yeah, thank you. Respected Dr. Vijay Bhatma, Professor and Head of the Department of Biotechnology, Dr. Parimal Alagan, Professor of Botany, Dr. Arun, Assistant Professor in the Department of Biotechnology, Dr. Satish, other faculty members from Department of Botany and Department of Biotechnology, and students from Bardea University and other academic institutions, and the invited speakers. I am extremely happy to be here for the joint program, the 3-day international webinar, where there is a basic science department, that is botany, joining with applied science, that is biotechnology, covering a large number of modern development in biotechnology. First of all, I would like to congratulate both the departments, both the Department of Botany, which has a rich history of starting from Madras University days, and produced several stalwarts, contributed a lot for the Department of Botany. Any science, the basic science is very important in terms of bringing the knowledge to the students. Unless you have the basic knowledge, it is not possible for you to go for any of the advanced one. And the other one, you have to go for the application. Nowadays, the application is being done in all the departments, which is called as a translational research. Bardea University is a good model for the inter-departmental research. That is a joining of more than 7 departments. We are going to have a builder program, and we are going to defend with the Department of Biotechnology. It's the best model in the country, where many life science departments join together and work for a common platform, developing the common platform like diagnostics or going for various other things related to biology. So here, I would like to emphasize there is a need for the joining of the people with the many qualifications as well as the capabilities. For example, bioinformatics. Whatever the time you have taken for bringing a diagnostic kit, it took 15 years for me to bring a diagnostic kit to come to the market. Of course, it is in the market for the last 15 years. I started my diagnostic kit development with antigen derived from the worms, which was not having the uniformity in the process, batch to batch variation. And I have gone for the genomic DNA for the ESTs, express sequence tag. Again, the expression was not very, stable. Then ultimately I went for the cDNA-based development of the diagnostic kit as well as the vaccine. As far as the diagnostic is, I took 15 years, but for vaccine development with development of modern bioinformatic approaches, it was possible for us to go for recombinant peptide vaccine within a short time, within 5 years. But nowadays, with the development of various techniques in biotechnology and biology, it will be possible for you to come to any conclusion within a short time of 3 months to 6 months to go for what is your target, which target you have to express it for diagnostics or prophylactics or for drug targets. This is a situation today. And in Bharatiya University, we are all very particular about going for the applied aspect. And Dr. Parimalagan is involved in promoting the people for IPR rights and motivating more and more people to go for the patents. And it's going on well. And in today's webinar, a large number of people who are going to talk about COVID-19, then plant biotechnology, bioenergy, and so many other modern areas in biotechnology, such as the information technology and how you are going to use the information technology in the teaching and research of biotechnology, especially to use industry's 4 components and industry's 5 components using the artificial intelligence, then augmented reality, and so many things we are already incorporated into the curriculum of almost all the branches of life sciences of Bharatiya University, courses. I wish the program every success. I request the people to make use of this platform to discuss each other, to make long-term collaboration with the academicians who are going to give a talk today. Thank you very much.
Thank you, sir. Now I request Dr. T. Parimelagan, Professor, Department of Botany, Bharatiya University, to deliver the felicitation address.
Yeah, very good morning to all of you. The most respected our Vice Chancellor and of our university, and Professor Vijay Padma and other organizers. I am pleased to welcome you to the international webinar on these advances in biological sciences organized by our department as well as the biotechnology from Bharatiya University. So it is a high time that such an event took place to highlight the remarkable contribution and applications make in so many areas of biological sciences. A glance through the list of presentation, if you are seeing in this brochure, the plan for the next few days reveals the amazing diversity in these biological sciences. And as we know that during the advancement of our biological sciences in the 20th century, separate fields evolved to tackle the complex view of system that together comprise the living system. So like the genetics, cell biology, microbiology, biochemistry, and molecular biology, each group deals with various aspects. So the sheer volume of this knowledge generated by each of these sub-disciplines makes it decreasingly difficult for the researchers who study organisms to keep up their progress being made by those studying cells and molecules. And most researchers, in the focus on a single system in a great deal. Of late, the connection among the fields of life sciences have become easier to study also. Despite the development of the common tools, questions, and methodologies, scientists within sub-disciplines still don't have the optimum level of interaction. So that is more important, and we have to collaborate each other and we can achieve a lot of things. And they must be provided with an opportunity to gain different skills and perspectives to accelerate the development of conceptual and technological approaches to understand the connection between the different types of biological systems. So participants, really, I think this webinar such as this provide a valuable opportunity for the academicians and even the research scientists, industry specialists, and decision makers, even for the scholars and the young minds to share their experiences also. So I'm grateful to many the experts who have come to share their knowledge in this webinar. I also welcome many students and scholars also who have joined with us. And really, it's a good opportunity to have a knowledgeable worth of webinar. And I am sure you will have a fruitful and rewarding exchanges in the next few days. I wish you very success with this important international webinar on these advances in biological sciences. organized by Dr. Gurusaravanan and Dr. Arun from Biotechnology Department. So really, I congratulate the organizers, Dr. Gurusaravanan from Department of Botany and Dr. Arun from Department of Biotechnology for the great effort to organize this meaningful webinar for the students and the researchers' benefit. So thank you so much, and thank you.
Thank you very much, sir. Next, I request Dr. Gurusaravanan, Assistant Professor, Department of Botany, Bharatiya University, to give a talk about this webinar session. Please, sir.
Respected Honorable Vice Chancellor of Bharatiya University, Dean of Science, Registrar, Convener and Co-Convener of this event, both the Department of Botany and Biotechnology faculty members, distinguished participants. So very good morning to all. On behalf of the Department of Botany and Biotechnology, Bharatiya University, I invite you all for the 3-day international webinar on advances in biological sciences, ABS 2020. We have invited 7 eminent personalities in different fields of life sciences are going to deliver valuable lecture in this event. In the following topics are diagnosis of COVID-19 and its associated respiratory infections, traditional and nuclear medicine for coronavirus, vaccine development for COVID-19, novel immune therapeutic avenues for COVID-19, plant molecular farming, technologies for crop genetic improvement. So this webinar is designed in such a way to gain more knowledge in the emerging fields of life sciences, which would be highly beneficial to the students and young researchers. So it has a great impact in almost all the domains of human life, health, food, and agriculture. I'm sure that this 3-day international webinar will disseminate knowledge on the development of potential drug for pandemic diseases. So the program also provides updated information on sustainable agriculture system to find out good health between need of food production. So this event is also aims to promote high quality research in the field of health and agriculture sector. So indeed, I wish to mark that about 1,600 participants have registered from different disciplines across the globe. Okay, once again, I warmly welcome you all. Thank you.
Thank you, sir. Finally, I request Dr. Arun Muthukrishnan, Assistant Professor, Department of Biotechnology, Bharatiya University, to give the vote of thanks. Welcome, sir.
So, good morning to all. So first of all, I'm very happy to stand for you all to deliver this vote of thanks. First and foremost, I deliver my sincere thanks to Honorable Vice Chancellor of this Bharatiya University, an eminent scientist and a great visionary person, Professor Dr. P. Kaliraj. So, Kaliraj sir, for graciously accepting our invitation to present the inaugural address for this function. And next, I am extending my sincere thanks to the registrar of this Bharatiya University, Dr. K. Murugan sir, for being a part of this webinar. Then I extend my sincere thanks to Dr. M. Ramesh sir, Dean, Faculty of Science and Professor of Zoology, for taking part in this webinar. And I also extend my welcome to Rajendran sir, who is the convener of this workshop and is a professor from Department of Botany, Bharatiya University. Thank you so much, sir. And I also extend my thanks for my own department HOD, Professor V. Vijayapatma Madam, for extending since time for giving us part in this webinar.
Yeah.
Then I also extend my sincere thanks for Parimalalan sir, who is the co-convener of this webinar and he's professor in botany of Bharatiya University. Thank you so much, sir. And I also extend my sincere thanks to all the faculty members from Department of Biotechnology and Botany for helping us and taking part in this webinar. And I also extend my sincere thanks for the speakers like Adjunct Professor Kelvin, Epiglobulin, and Dr. R. Rajesh Kumar, Dr. G. Ashok, and Dr. S. Karthikeyan, Dr. T. Muthamil Chelvan, and Dr. K. Chandrasekhar, and Dr. S. Vinod. So who are all from different places who kindly accepted our invitation and also like take part in this webinar. So I thank all the speakers as well as the resource persons. And finally, I thank all the participants who have all applied for this webinar. And like it's my thing to close this inaugural function. So right away, I will just proceed to the first session as the speaker has right now joined. So Dr. Gurusaravanan. Gurusaravanan.
Yes, yes.
Yeah, okay. So shall we start the first session?
Yeah, sure. Anna, you just introduce about Kevin, sir.
Yeah, okay.
You have a biodata. You welcome Kevin, sir.
So good morning,
Kevin,
participants.
Sir. Kevin, sir, please unmute your audio. Kevin, sir. Yeah, thank you, sir.
So good morning, participants. So everyone who are all around here in this webinar. So I welcome you all for the first session of this webinar, like Advances in Biological Science 2020. So I'm very happy and I'm very proud to introduce you eminent scientist and resource person who like Kevin Epiglobulin. So he's the vice president of our research and development, and he's the quality for regulatory in the lab systems diagnosis in Finland. Okay, so Professor did his R&D in quality management, and he is involved in commercially viable diagnostics for newborn screen test. Okay, so he has also previously served as a senior developmental manager in Orion Diagnostics OY, and which is a leading European in vitro diagnostics company. Okay, so Professor has a very long history of track record, which is around 20 years, which is in managing early technology concepts in commercializing in vitro diagnostics. So there is his most important credential. So he also extends his research in biotechnology and developing medical device products. He also involved in developing several technologies for novel nucleic acid amplification technology, resulting in commercial of several in vitro medical device products. Kevin has also played a leading role in several business development deals and currently serving as a mentor as the member advisory board for several startup companies in SMEs. And he also holds a master degree in molecular biotechnology from the University of Essex, UK, and he did his PhD in bioengineering from the University of Sheffield, UK. And he also holds an MBA degree from the Aalto Business School, Finland. And he also holds several academic positions like in the University of Helsinki, Finland, as an adjunct professor in molecular biology. And he is an author and inventor of several scientific articles and patents related to diagnostical technologies and products. So Kevin, sir, we wholeheartedly welcome you for this webinar, and I hope your talk will be really knowledge sharing for all the participants. So I will welcome you, sir. So now I will hand over the webinar session to Kevin, sir. Thank you so much.
So good morning, everyone. Can you see my screen? Just to double check if you can see my screen. I'm trying to share my slides, so just double check it.
Yes, sir.
Yeah, the slides are visible, Dr.
Your
Kevin.
slide is very clear, shared.
Okay, great. So good morning, everyone. It's a pleasure to be here with respected academics. I'm really here to just give some updates about rapid diagnostics for respiratory infection. I know COVID has really been a new hot topic now, but actually respiratory infection has been something of a, quite a big issue for us for a long time now. So thanks for the introduction. So I work for Lab System Diagnostics. I head the R&D and quality and regulatory here. As a part-time position, I also work at the university teaching and also collaborating with researchers. So I hope that my slides will give a little bit of an overview of what is happening in the respiratory diagnostic section. So let's move this slide. Okay, so a little bit about the background. This is already quite clear, but of course, respiratory infections just mean any infections that is associated with the respiratory tract. So this could be an upper respiratory infection or lower respiratory tract infection. Typically, upper respiratory tract infection with the nose, the nasopharynx, they are usually mild, but in terms of the lower respiratory infections, that can lead to actually pneumonia and sometimes in some cases death. So just to remind everyone about the respiratory infection, I know that we are all talking about COVID. So really respiratory infection is one of the leading cause of death already. So it's something we know. This figure is already in 2016. And so this is already prior to COVID. So already, it's already the leading cause of death in across the world. But actually, when you look in terms of low-income countries, developing countries, for example, lower respiratory infection is actually the most cause of death already. So in a way, prior to even COVID, respiratory infection has been a really world health burden. And of course, we need to find ways, new tools, new technology to address this infection. So just to come back, what is really responsible for respiratory infection? Of course, the cause could be a virus, it could be a bacteria or fungi, or sometimes or everything. For example, influenza is one of the most prominent one. RSV, for example, is another prominent one. And actually, every child, I think every child up before the age of 3 would have had RSV infection. So of course, that's another leading respiratory pathogen. And most likely, most recently, in the last few months, we've had severe acute respiratory syndrome, SARS-CoV-2, and of course, that's been quite huge and has a huge health and also economic impact as well. So I wanted to put a little bit of numbers again just before COVID. If you look across the globe, it really, for example, influenza, seasonal flu really affects every country, every nation. And from the last data a few years ago, I think about almost it leads to annual death of 700,000. So this is quite huge. So, so even prior to COVID, we've had a big issue with respiratory infection and also the healthcare and economic bundle that comes with respiratory infection. So I wanted to put a little bit of also numbers. So it's good to look at the impact also from an economic point of view. I know currently I'm using the US also because US probably has the highest number of cases of COVID-19. But really, I wanted us to look at actually what about influenza, for example. So we look at the numbers in the US. Really, you get around almost 100,000 deaths annually, and no one really talks about it or know about it. Hospitalization associated with influenza, for example, can be about 1 million cases per year. And influenza outbreak or cases, even with the use of vaccines, can get up to 30 million cases annually in the US. So the economic impact already is estimated to be about 35 billion US dollars annually. So the reason why I'm showing these numbers also is that actually respiratory infection has been has a big impact on our healthcare system and also to the economy as well, even before COVID. What COVID has actually done is really to re-emphasize the need for appropriate care and appropriate treatment. for respiratory infection. Okay, so this is where diagnosis really come into play. Usually respiratory infections, the pathogens that are responsible show identical clinical signs and symptoms. Hello, can you hear me? Yes, okay. So usually respiratory pathogens, whether influenza, whether COVID, whether the RSV, they also very similar clinical signs and symptoms, which means it's very difficult for the clinicians to diagnose what the pathogen actually is by, do you have pneumonia, cough, runny nose? It's very difficult. You cannot say whether you have influenza, whether you have mycoplasma or RSV. So the only way to really do this is by developing, using accurate diagnostic tests. So by using diagnostic tests, you're able to actually identify the right pathogen responsible for the respiratory infection, also able to decide appropriate treatment. Do you use an antibiotic or not for treatment? In some cases, for example, strep or mycoplasma, those are bacteria, so you can use antibiotics. Or in the case of flu or viruses, antibiotics are not really useful in that sense. So it's not only important to identify the pathogen, also the use of diagnostic tests is important for controlling the infection and also minimizing unnecessary use of antibiotics. Of course, antibiotics, for example, it's also antibiotic resistance are becoming quite a big factor as well. So I'm not going to review all the diagnostic tests currently used in for a respiratory infection, but you can get, this slide just gives you an example of what the landscape looks like. So initially you can find rapid tests are quite good to an extent. They are fast and you get the result quite quickly. But in some cases, there are issues with sensitivity. So then the molecular test is also one, namely PCR. Microarrays has also been used as well. And actually, as time goes on, due to the need for timely, the need for rapid and point of care testing, a lot of this technology has been evolving quite rapidly. And we see that this will continue to change as the requirement and also the regulatory requirement changes as well. So I try to summarize what we see in terms of method or techniques used out there for diagnosis of respiratory infection. So let's see if you can, there's a table, I don't know if you can see that already, that looks at typical performance of different methods. So like I said before, the rapid test, which would be something that an antibody-based method that detects the antigen itself, either protein or just the whole virus. Typically, these are very, very good because they are quite fast. They give you can use this method at the point of care, close to the patient. But sometimes we've found issues with sensitivity as well. Viral culture, I'm not even sure, it's mainly now used for confirmation. But as you can see, 1 to 3 days it takes to do a viral culture. That is quite a long time. I think it's too long nowadays, and it's really not something it's used only really for confirmation. Serological tests that you've seen on the media, people have claimed that serological tests, or at least the rapid antibody-based tests for IgG, IgM are not sensitive enough and probably not recommended for the diagnosis of COVID. And I think the same applies also in other respiratory pathogens, because the antibodies against those pathogens usually comes maybe 2 or 3 days after the infection. But it's not really quick enough. But having said that, there are advantages in terms of speed, able to use this test in the field. The one really, which is really highlighted in green, which has now become really the gold standard in diagnosis of respiratory infection, is really the molecular test, namely RT-PCR. But also, we can start to see also a move, more rapid, more faster molecular tests now coming into the market. Next generation sequencing, actually also it's been quite huge and currently now being adopted for diagnosis of respiratory infection. But currently we still see a 24-hour turnaround time, and really with some of these infections, you want to be able to get the result very quickly. So like I mentioned already, and I will probably not go too much in details into real-time PCR because it's become now a gold standard. Everyone is familiar with the technique and with the method. But it's still good to visit it very quickly. Of course, it could be the method, it's real time. It can be based on probes or intercalating dyes. The reason why I'm showing a slide on real-time PCR is that really there are limitations of the current method, and also this is really one of the drivers we see for new trend in respiratory diagnosis. So one of the limitations, for example, could be, it's quite expensive compared to a rapid test. It's too slow. Sometimes you want to be able to find out whether a patient has influenza or COVID very, very quickly, preferably in minutes, so that you can either isolate or send them home or decide what kind of treatment you are doing. Secondly, another limitations of PCR really is that most of the method requires an extraction step, and that in itself can take a long time to do, and sometimes becomes a bottleneck in the use of RT-PCR itself. And finally, in some cases, you want to be able to use your diagnosis test in the field. So maybe in elderly home care, maybe even on the street in the pharmacy. Most of these cases, the instrument used are a little bit more complex and requires someone who has some experience in using the technique. So it really then comes back to maybe the aim of my presentation today, and what I wanted to show in terms of some of the trends that are happening in diagnostics of respiratory infection. So, as I mentioned already, the trend that we are seeing really for rapid diagnostics or diagnosis of respiratory infections are actually meant to address the limitations of RT-PCR, because RT-PCR has become now the gold standard. So, for example, the need to have a miniaturized instrument. You want to be able to run your test with a small instrument or no instrument at all has led to, say, the development of alternative methods for amplifying nucleic acid. Also, sometimes you want to know a little bit about the sequence information. What is the strain of the COVID-19 that is spreading? What is the strain of influenza? In that case, RT-PCR cannot really offer the right information. And sometimes you want to improve your sensitivity. There are limitations that I don't know how much people know about sampling of COVID, for example, or influenza through nasopharyngeal swabs. Typically, I've tried it myself. They're not very pleasant when you take samples. I think some of the patients, I remember my daughter also she's only 3, and nasopharyngeal swab was taken from her, and it was not really nice, I have to say. So some of the patients might also want to have this kind of non-invasive sampling, and to do that, you need some method which is even more sensitive than the PCR itself, the conventional PCR. This is where, for example, droplet PCR will come into play. And also, like I said, rather than wait for 2 or 3 hours to get your results, you want to have a result in minutes. And this is where isothermal amplification methods also come into play. So these are really the drivers of the trend that we see in respiratory diagnostics. They are usually based on the trends we see are usually based on the limitations of the current technologies. So for example, droplet cyber PCR is a slight upgrade from the conventional real-time PCR, where in real-time PCR, you just measure a box sample and amplify and detect. But slightly what we are seeing now is that droplet digital PCR is now being adopted for diagnosis of respiratory infection. So the main difference between droplet and the standard RT-PCR is that you first of all generate thousands of droplets, and those droplets, individual droplets, become individual PCR reactions. And in that case, you're able to rapidly really improve the sensitivity of your detection and improve your detection limit quite dramatically. So this is something that has recently also been adopted for influenza. And actually, there's an article out there, this is probably about 2 months ago, where they've applied now the use of droplet PCR for high sensitive detection of SARS-2. So this was also a breakthrough, and clearly the authors can really demonstrate that actually there was a really remarkably improved sensitivity, particularly when you take samples from throat swabs where the viral load in those metrics are quite small. So I envisage, I can imagine that this method in future will be used for detecting for non-invasive detection of COVID-19, SARS-2, or also influenza, say for example, from saliva or from urine. So this is something that we expect to see in the next few years, that this could be in the market as well. By using this kind of high sensitive method, you're able to then develop tests which are non-invasive. And I think that the patient also will be quite happy. So I think we all know about next generation sequencing already, and I will probably not go too much in details, but again, the reason why NGS is now used for, in our case, for respiratory diagnosis is also back to the limitations of the current method, RT-PCR, because we really want to have the information about the sequence, the strain that is spreading. So therefore, next generation sequencing became quite important, has a role to play in diagnosis of respiratory infection. Like, having said that anyway, it's still evolving. The instrument is still fairly expensive. So, so very few labs do have NGS capabilities. Well, very recently, only I think this is about 5 weeks ago, Illumina was the first one now to show the use of next generation sequencing for the diagnosis of COVID-19. When I looked at the information from the manufacturer, of course, I can already see that there are limitations even on the current test, and it requires 1,000 copies per genome of the viral genome per mil. So I think that's still, the sensitivity is still quite, maybe not as good enough as RT-PCR. I know, of course, there's still a 24-hour turnaround time. So this is still current limitations. But of course, this is clearly, there is a need to have sequence information about what the pathogen is, what the information, what the sequence information, you need the sequence information to be able to sometimes decide the right treatment. So I think that, for example, next generation sequencing is likely to become more and more adopted, readily adopted within the clinical setting. So taking, for example, sequencing also further, we can already see also the use of single-cell RNA sequencing for the diagnosis of respiratory infection. So what is really clear different here, what is really a differentiator here is that the use of RNA-seq, for example, not only tells you about maybe the disease state or the infection, but it can even go as far as telling you about what cell the pathogen is actually infecting, T cells, beta cells, what's the nature of the cells. So in a way, you're able to do some form of targeted treatment using this method. Similar to sequencing, but the only difference is that the cells are actually tagged into droplets, so you're able to amplify, run like qPCR and sequencing of individual cells rather than having this kind of bulk mixture. So you can see here, this was applied about a year ago for the diagnosis of influenza. And, you know, this gave a great insight to what cell the influenza strain, it gave information about the strain, the sequence information, and also gave information about what cell actually influenza is targeting. So you can see that using this kind of method really adds value in terms of patient treatment, because it also tells you the location, which cells are being affected, and it also gives you information about the sequence composition of influenza. So we can see this trend coming quite quickly, and it's something that will be really, really readily adopted in future. But it's still early days. But I think that the next slide really is, you probably have heard about, most people have heard about CRISPR, but CRISPR is really associated with gene editing, not really related to diagnostics, but actually what has happened in the last 2 years already, there has been really the adoption of CRISPR as a diagnostic tool as well. So there's been two institutes, the MIT and also University of California, really driving the use of CRISPR for rapid diagnostics of infection. They've actually, both institutes have actually come up with fairly similar methods for diagnostics. They've been able to develop a variant of Cas9, which is the Cas12 or Cas12-13. They leverage the specificity of this protein, and then this protein acts like a probe for specific cleavage of specific detection of pathogen. And I don't know if anyone have checked this already. So that is usually how the method works. They still need to have some form of amplification, pre-amplification by some form of isothermal method, and then use CRISPR for direct detection of the sequence of interest. And quite recently, 2 months ago, I think the first company called Sherlock Biosciences in MIT showed now actually have a kit in the market, but currently only in the US for detection of COVID-19 already. So this is a technology really that's only been here for a year or two, and now it's now being adopted within the clinical settings as well. So we see more of these kind of technologies being adopted within the clinical settings, because in this case, it offers improved sensitivity and also can be used in without an instrument. So far, I've kind of like run through some of the trends, and most of the trends really are, like I said before, are meant to address the current limitations that we have. But looking a little bit further, I thought I will go a little bit more details in maybe one of the technologies, for example, also because I have spent a little bit more time on also this technology as well in the past. Like I said, a lot of these trends in terms of technologies we see are related to limitations of the PCR. So one of the limitations that we find in PCR is that you need a bigger instrument, like I mentioned. You need some instrument to be able to do the detection. You want to be able to get the result very, very quickly. So already this method, LAMP, for example, is one of the first isothermal based DNA or RNA amplification method that don't require thermocycline as seen in RT-PCR. So in this case, because you can run these reactions at low and constant temperature, it means that you really don't need the device to run the reactions. You may be able to even develop very small footprint, or actually develop some form of immunoassay-based type approach and adopt LAMP, for example, for the detection of respiratory infection. And one thing I also like about LAMP is that it's really, in most cases, an instrument-free. So you're able to actually visually inspect whether there is a positive reaction or not. And you can run some of these tests or whatever, even a mobile phone or just a normal incubator. You are able to use this method for rapid detection already of respiratory infections. I didn't show any slide on LAMP, but I know if you look in the literature, there are already thousands of publications on the use of LAMP for COVID-19, for RSV, for influenza. So this is one benefit that this method brings in, is that you don't need a thermocycler, and most likely you don't actually need to do DNA or RNA extraction. So this will add value, particularly to limit low resource settings and also within the point of care settings. Typically, this method only relies on a strand displacement polymerase and 4 to 6 primers that really generate a cascade of sequence that becomes quite specific, and you're able to detect. But there will be some information there. You can easily check about LAMP out. There is another, I don't know if anyone is also familiar with the next one I'm trying to present here. It's also an isothermal-based amplification method called strand invasion-based amplification method. Very similar to RT-PCR, LAMP, also similar to RT-PCR in that sense. The only difference here is that this method, it's run at low and constant temperature, typically 41 degrees. So there is no thermocycling needed. The specificity that you get is still similar to RT-PCR. The advantage you get now is that you don't need any big instrument for amplifying the method. The method now is really based on a recombinase. So recombinase, as you know, recombinase are really proteins that helps to repair DNA damage. We have leveraged that capability and used that for specific denaturation of double-strand duplex. By having some target-specific primers, you're able to invade a specific sequence, use a primer, and in presence of a specific DNA polymerase, quite quickly generate exponential amplification of a target sequence. Detection is very similar to RT-PCR, so this could be by target-specific probes or by cyber-grain intercalating dye, for example. So I show, so like I said, we find very, very similar performance with real-time PCR and this method called RT-Cyber. So for example, when we see detection of influenza using this method, you're able to detect from sample to result as low as 10 copies in under 20 minutes. So that's quite fast if you want to compare that to RT-PCR, for example. And you can specifically distinguish between influenza A or influenza B using this method. I think this was something we, for example, we compared, look at the clinical performance of RT-Cyber compared to RT-PCR, for example. Looking at the limit of detection, you're able to detect, say, for example, at the limit of detection from sample to result within 17 minutes of starting the reaction, compared to RT-PCR, where you can actually, it takes you about 2 to 3 hours to detect. We also find similar clinical performance when you use over 150 nasopharyngeal swabs and aspirate. Very similar performance with RT-PCR. So we see methods like these where instruments are not needed and also time to result is quicker. We see a method like this will become readily adopted within the clinical setting. Having said that, there are new technologies are always coming out on a daily basis or on a yearly basis, but of course they all have their own limitations as well. So I showed another example of the use of RT-Cyber for rapid detection of respiratory infection. So for example, in strep A, this was something published a few years back, where from the swab to the result at the same kind of similar specificity and sensitivity as RT-PCR, you're able to get this result within 8 minutes. So we see that big benefit for having this kind of method within the clinical setting. So you can imagine a patient goes to the hospital or see their GP. The GP is able to specifically say, run the test very quickly in 10 minutes to say, hey, you have influenza, so I'm not giving you antibiotics today, you can go home, or at least decide the right treatment. So we see this now more and more as really a future trend of diagnostics in respiratory infections. So I've tried to give a little bit of snapshot of some of the things that are happening, but I've also given you some things that I feel that are very close to the market already. So I know that there will be tons of other technologies out there being used, but if we look to the future, how we see respiratory infection diagnosis will look like, it's going to be very difficult to say which technology, which method will be used. So, however, a lot of the technologies will be related to limitations addressing these kind of drivers, addressing the current limitations. But beyond that, I think that I always like to use this slide is that I've seen very good technologies in the past and they were never adopted within clinical settings. The reason is it's sometimes nothing to do with how good the technology is, but actually there are a lot of things, even developers of technologies, users of technologies really need to think about when developing this test or using a technology. The drivers are sometimes not how good the technology is. It may be just a government policy that say, hey, we are not going to use RT-PCR, we will use point of care, and that's good enough. We will use immunoassay, we will use rapid antigen test. That might be the reason, and development of a technology will not progress. Secondly, we see quite a lot of regulatory constraints, more and more demand for manufacturers from the regulatory side. So the new IVDR in Europe, for example, is coming. FDA is, imposing tighter regulations. So, which means that new methods and new trends, new technologies, some of them may not be adopted within the clinical settings because they don't meet the current regulatory standards. And also, some technologies might be used because it's fashionable. Nowadays, patients themselves are starting to decide which technology they use, and not necessarily the clinicians. So we can see also more and more cases where patients run the test themselves and not the clinicians or not their lab technicians. So this is what will happen. And also the rise of the middle class, people are getting even wealthier as well. So we see that there will be more control in terms of diagnostics will be decided really by the patient, by the user, rather than actually by the clinicians. Of course, we see now the need for home testing, for example, in the case of COVID. I think that now a lot of people will like to run some of these COVID tests themselves. But if you can also imagine, even though there are actually methods that can be run at home, rapid tests, currently, I believe there is only one rapid test that have been approved for home use for COVID-19 diagnostics. So in that sense, there are technologies out there for home testing and self-testing. But for example, regulatory constraints and maybe quality issues have prevented this from being adopted. So looking at the future in terms of trends, we will see now the need for non-invasive testing of respiratory infections. So people want to be able to decide for themselves whether should I stay home, should I go to work, or should I stay home? I have flu today, I have a running nose. So they want to run this at home. There's no need to come to the office to then, transmit that infection within the office. So we see this kind of paradigm shift also in healthcare and also in diagnostics. As you know already, we all know about artificial intelligence. I think this also will be something that will be adopted as well. So I think that, for example, biotechnology has a big role to play in terms of future diagnostics, but I think it also will be combined with a lot of things that from the regulatory side and also from the government policies, and also patients themselves will have a big role to play in terms of which technologies to use in the future. So I hope that I've been able to give you a little bit of, I think it will be difficult to give you a more in-depth view about trends in terms of respiratory diagnostics within the time limit, but I hope that you have at least gained some insight into some of the trends that are happening in diagnosis of respiratory infection. So thank you very much for your time, and thank you for listening.
Thank you, Dr. Kevin Boybodin. There are some questions from the audience which I would like to ask.
Sure.
The first question is from Ms. Rekha, and she's asking, what is the advantage of using quantitative RT-PCR over LAMP in terms of sensitivity?
So basically, sometimes so it depends on the assay. What we have seen with LAMP, we have seen very, very similar sensitivity as RT-PCR, and in some cases, LAMP has shown a better sensitivity for the diagnosis of respiratory infection than RT-PCR. So there's been, two conflicting sides. Some articles may show some sensitivity, superiority of RT-PCR, some might not. But from my opinion, I think they display very, very similar sensitivity. The main advantage here for LAMP is that you can use it with a small footprint or no instrument.
Yes, thank you. Same person has asked one more question, like how to overcome getting false negatives in quantitative PCR? Is it with respect to setting viral load concentrations in specimens?
Yes. So really, false negative. One rule in diagnostics that we say is that your test is as good as your sample. So we already know that RT-PCR is very, very sensitive and sensitive to sometimes a single molecule, but you still have issues of false negative. So what that means is that you're only as good, RT-PCR is only as good as the sample. So which means that sampling plays a big role in sensitivity of RT-PCR and also in diagnostics. So in terms of how to get rid of false negative, so really you just then need to increase the concentration of the viral load in your sample. Or in this case, you will want to adopt digital PCR because that will be a bit more sensitive than RT-PCR.
Another question from Mr. Charles. The question is, can recombinase polymerase amplification technique be used to diagnose COVID-19?
Yes, absolutely. I think it's already been shown. There are 1 or 2 articles on it already. I know personally myself that it's been done, but that's not public information, so I couldn't share that. Yes, that has been demonstrated already. COVID-19, in terms of the sequence and the nature of the sequence, it's not different from RSV or influenza, which have already been shown with recombinase polymerase amplification. So in that sense, your answer to your question is yes.
Next question from Ms. Namita. The question is, what about the cost effectiveness of the different diagnostic methods discussed?
I think that's a good question, and actually it's also one of the key drivers for deciding which method to use. Currently, still the most expensive test in terms of design, it's still RT-PCR. But if you compare it to other isothermal methods, I think RT-PCR now, the prices are fairly low. LAMP, for example, the cost is also quite low. So I think it depends on the whole design of the test. So it's sometimes quite difficult to say which is more expensive because the technology itself, RT-PCR, LAMP, or RP, sometimes they are only a very small part of the final cost of the test. So therefore, it's also very difficult to make give you a concrete answer which is more expensive.
Thank you, sir. Next, another question from Ms. Preeta Mukherjee. She's asking, like, do you think this new SARS-CoV-2 has a good amount of sequence similarity to earlier discovered SARS or influenza strains?
I myself have looked at, I think, 4,000 sequence. So there are some similarities, but also there are some dissimilarities. The pattern of infection of SARS-2, it's probably still not well known yet, but actually it's still not much different from the normal seasonal coronavirus that we see. So I think that we can already see similarities with influenza. Yes.
Thank you. Same person has asked one more question, like, do you think antisense mRNAs or interferons can be of good use in therapy as vaccine development is a more critical process?
I think time will tell. Of course, vaccine has a big role to play. So actually, there is a possibility that yes, there might be a benefit of doing that. But I must also say that I know that there's been also a big publicity about the use of vaccines. I mean, I showed you number of deaths of influenza and respiratory infection. And remember, there's already been vaccination for the past, I don't know, years now. And we still see quite a high number of deaths related to influenza. So even when we do have vaccines for COVID-19, we will still face still quite a lot of issues in terms of illness related to COVID-19. And this is where really diagnosis come into play. So having the right method that takes you, is it influenza or is it COVID-19? This is something that will still have a big role to play in future.
Next question from Tripura Sundari, she's asking, is there any preventive measures for pandemic disease?
Yes, I know. That's the right answer. So I think that if we, prevention will be, in a way, having the right tools in place when this happens, right awareness, hygiene, more like more education for everyone. That's way to really sometimes prevent this pandemic. But also, if I looked at the Spanish flu, some of the pandemic in the past, they bring some new challenges which we are never prepared for, and we have to learn very quickly. So I think in general, being aware, health conscious, being aware of taking care of your health and hygiene will also be a way to minimize impact of pandemic.
Thank you, Dr. Kevin.
Thank you.
Madam, no more question? Yeah, madam.
No, sir.
Okay.
Almost everything is being answered.
Okay, madam. Okay. Professor Kevin sir, thank you so much. Professor Kevin sir, good afternoon. Thank you so much for your valuable information. So you well explained about the most prominent cases about influenza viruses, and also focusing the emerging trends and the limitation of qPCR, CRISPR diagnosis beyond gene editing, and diagnosis of COVID-19 and its associated respiratory infection. I hope the participants are enjoying and learn a few things from your presentation. So I thank you so much for your support, sir. Thank you.
My pleasure. Thank you very much.
Thank you, sir. Thank you. Yeah. Sir.
I also personally thank you for giving a wonderful, very good presentation, and we all learned new things about this at this pandemic time. Your presentation is highly useful for us and also for the participants. So on behalf of Department of Botany and Biotechnology of Bardar University, I thank you for your wonderful presentation, sir. And also, in future also, we try to have a very good collaboration and interaction for working towards the research and development. Thank you so much.
Thank you very much. Sure.
Thank you, Dr. Kevin. This is Professor Parimal.
Yeah, hello. Yes, thanks for inviting me. Hello,
Yeah,
thank you.
Thank you so much because with a short time you have accepted to deliver a lecture. The lecture was very impressive, and definitely I hope that all the participants they might have enjoyed your lecture. Thank you, Dr. Kevin.
Thank you very much. My pleasure.
Thank you, Professor.
Thank you. Bye.
So much for your and now okay, so now meeting in two platforms, that is Zoom, and we are also broadcasting the same in the YouTube. And accommodate more maximum participants able to connect to the Zoom platform. I kindly request you to go on more. Our doubts to the speaker. So please, persons who are not able to connect in Zoom, you please we will also post all the information in our Telegram group, which is particularly specifically forum. Then now information is our hosted by Dr. R. Rajesh Kumar, he's a scientist from China. In the like will be around 4 p.m. Okay, around 4 p.m. Indian time. So you please join using the Zoom platform. And I repeat, if you are not able to connect using Zoom, I kindly request you to directly use our YouTube page, right? So already we have shared you our YouTube channel link, and the same thing we will also share in your Telegram group. Okay, instantly we will share your Telegram group. Thank you so much. For the second session, we will meet you all around 4 p.m. Thank you.
Thank you. So we will meet again at 4 p.m. Thank you. Thank you so much. Close பண்ணிடலாம்.